record. So we want to create a listener. If you ever ask, create a listener from the notes that we read the other day, you could actually go to listener.aura and you go edit it manually and enter the stuff in it. But frankly speaking, that's above the scope of us here dealing with it. But we were told in the notebook, in the textbook, that you use the graphical user tools. And the best of them is Net Manager. Net Manager is better than Net CA. Does more. So I'll type Net Manager and I'll always put ampersand. But no, let me do without ampersand. You guys see why I use ampersand. When I type that, that thing is going to come up like this. If it comes up, let's say I actually came here and I did, let me just pretend here, I want to add my listener. What did I say you call it? BT1? Yeah. So I do that and I click OK and I add my listening address. Then I come back to this window and I accidentally, I want you guys to watch this. Let's say I came back to this window. See, this is Net Manager that came up. I came to where I started it and I accidentally do that. You notice that window closed behind me, right? But if I did that little ampersand, that ampersand in Unix actually says the program that is starting now will run in the background, independent of that window, of that command. So if I do that and that thing comes up, it's up on my other screen. This is it. I can come here and I continue to use this screen for other things. You see that? While this guy is running. That's why I put that ampersand. It's not a mandatory thing, but I put it there just for continuity. So I can continue to use this screen, this terminal. So, do a listener, guys, means I do this. I go here. See, that one I added is gone because that window closed without saving. So I click add BT1. That's my listener. Click OK, and that's it. Guys, remember, you could always come here and click on help. If you click on help, help will open up and it will explain everything to you. All the windows that we're using, there's a help command. And because that help is right there, there is really no point for me to come in class and I go explain everything again. Because if you go home and you want to know more, you get to any window, just click help and you read what help says. Please, everything we do, there's a help right there. Okay? So, but I wouldn't be reading that. I'll just show you guys the most important thing. So once you get here, practically, you add the address. And you can remove the address. Add and remove. So here, you see no listening locations configured. Press the add address below. So I click on that, you always come up with the default name. So it's right there. Then I can decide to add my database to this thing now. If I want to add a database, I click here and I go to database services. Oop, the port is already in use. Yes. So I change it to, we put 23 there. It just wants a port that is not being used by anybody. So I go back here, databases. Now add database. And my database is class T. Oops, I just got rid of my Oracle Home. I hit typing, that's what I'm going to do remove. I do add again. And class T. And my Oracle seed. Seed here is your Oracle seed. So I do class T again. Then guys, I've done that. I must save these changes. But before I change it, I want you guys to watch something. Let me come back to this screen. Okay, you guys know my OH takes me to Oracle Home. That's my alias. Because I go to Oracle Home often, right? I make an alias for it. Does that make sense? Yeah. Instead of me typing CD $ Oracle Home, okay, I just type OH. Because it's my alias I made. You can make your own alias, you call it K. So if you type the word K and hit enter, it takes you to Oracle Home. You get that? So anything that you do over and over and over, is good to do your alias. So you can use that all the time. That will save you time. Guys, because saving one keystroke 1,000,000 times would save you so much time at work, and you'll be much more free to do other things. So guys, so I'm right in my Oracle home, but I know I'm going to network. I type NE and I hit tab. You guys see that? And I know in that folder there's only one A. So I hit A and I hit tab. You guys notice that? Yeah. I don't have to keep typing the whole thing like a fool, because I've done this, I've gone through this many times. I know the names of the folder, so I can just do that. And if I think I'll keep going here every day, I'll make an alias to go there. So LL, I want you guys to watch. If I do more on my listener, right now it is, let me see, is it listening to anybody? There's only one listener called listener. That's the name of the listener. But if I come back here now that I added this, if I do file, save network, if I do this again, more, now it's much longer, and there goes my DT. You guys see that? So I got my two listeners now. There's a listener with this one, and there's the default listener. And you can see that port, 1523 that I did. You could make it any port you want, as long as the port is not being used. So I have my listener. Now I need to start this new listener. LSNR, that stands for listener. CTL stands for control, because this thing is called listener control utility. So if I type listener control, then I do start, let's just do status. And what's my listener name now? BT1. It's going to tell me no listener. Yep, error, but most importantly, no listener. So, and notice, listener errors start with TLS. Database errors start with Aura dash. You guys remember that? All database errors begin with Aura dash. TNS errors begin with TNS dash. Which one? This one?
No, the command you just typed.
So the command I just typed?
Yeah.
That is status. I don't have to spell the whole word. I can just put start. But if I like typing, I add the US. Guys, if I save that US, that saves a couple of cells in my fingers. Or cell, yes, it saves something in my body. So, but that command is to see if the listener is running. Because it's not running, now I bring back the command and I go add an R. See, instead of me typing the whole thing, guys, use upper arrow, bam, put the R, is now change word start to status to start. Hit enter. And you see now the listener command successful, so it's running. So right now, if I go back to that first command, hit enter, it tells me it's running. And it's listening to one service. A service is a database. It's listening to one service. And you always see this stupid thing here. And I've never really found out what it is. You're always going to see the status unknown stuff. It's always there. But don't worry about that. So this is it. But guys, watch that. Uptime. My listeners are running only for 8 seconds. You guys see that? So you can log in to find out how long has this listener been running by checking status. Then the next thing, start date. Even tell you the date the thing was started. And the name. Name is also the alias. But watch this, guys. The listener parameter file. It tells you where the listener.aura is located. It is that file that we edit to make the listener run. You get rid of that file, listener will never start. Change one thing inside that file. Put a little comma in there somewhere. Listener will never start again. Okay. Then, everybody also watch. There is a listener log file located somewhere else. I want you guys to watch. Under DAIG. TNS. It's not inside Oracle Home. Now it's just under Oracle-based DIAG. Remember, what is that again? DIAG is where the alert lock is. You remember that, right? So there's a listener in there. and the log file is an XML file. It's under a folder called alert. Let me see what else. Guys, what's another thing when you do this thing, what you're looking for? You're looking for this line, because this line will tell you like what protocol is being used, the host name, but it says local host, means it's on this machine. It's not a listener on another machine. And it gives you the port number, very important. And at the top, it gave that too anyway. Then it gives you the version of your Oracle database, because the listener version is the same as version of the Oracle. So, but guys, I have 2 listeners running. This is the big question, everyone. If I have 2 listeners running right now, let me just see, let me check something. If I do just listener start, I'm checking for the default listener called listener. See the alias is listener? For the default, I don't have to put the name of the listener. But now, this is the big question. I have 2 listeners running. Let's say this was a brand new machine they gave me. I don't know the names of the listener, but I want to find out what they are. I would use PS -EF. -EF, fingers on the wrong place. Pipe, grep. Oh, by the way, if I just type that and hit enter, you guys see what it shows me? Hundreds of lines. Every process running on this machine. Everybody pay attention to this one, Lyndon. If you ever type this command, PS-EF, and hit enter, it shows you all processes, 1,000 of them or 2,000 running on this Unix machine. But I don't want to see all of them. I want to see some. If I want to see the database listeners, the database processes, I will do pipe. Pipe is like, okay, all the processes are over here, but the ones that I want to see, grep, of all this is like a dump. You have all the processes list over here, right? We want to filter them and only see the ones that have a certain name. So I do PS-EF, pipe. That pipe is like a bridge, like a dam, right? Then you say grep, you copy. We say grep, it's like grab. Only pick the ones that have certain words. Aura underscore. When we put Aura underscore, because we know this as a DBA, everybody knows. Or Oracle processes begin with Aura underscore. Everybody write that down, guys. Don't just listen. When I'm talking, you're gonna have your pen and you're writing down something, Lyndon. Where's your notebook? You're writing down something, because I say this tomorrow. I don't want to repeat this again. All Oracle processes begin with Aura underscore. Okay. Every Oracle process begins with Aura, and that Aura is lowercase. Aura underscore, not Aura dash. All Oracle processes. Therefore, if I do this, everybody watch. If I do this, PS-EF pipe grep, everybody in this class must know what grep is. Grep is a filter. We have all these things, but I want to filter. Give me just some. Grep Aura underscore. I want you guys to watch, and I hit enter. It shows me a ton of processes. I want you guys to watch here carefully and see what the names look like. I want you guys to see, people. Everybody watch the screen. When I type that command, it gave me this bunch of processes. I want you guys to watch carefully. Number 1 here is the owner of the process. And the next one is the process ID. Process ID. And the time the process was created or actually got started. When it got started. And most importantly, the name of the process is at the end. That's the name of the process right here. And for every DBA, you must know this. Aura underscore is just a prefix for all Oracle background processes. Then the next thing is the name of the process. And the next thing is the name of the instance or database, name of the instance, as a matter of fact. Instance name. So there is an instance called class P and there's an instance called class T running on this machine right now. Then if you go down, for example, everybody knows Pmon. So there's Pmon for class T. So if I go down, I'm going to see Pmon for class P. You see that? So instead of me saying, if I had 20 databases, right, this would give me like some 300 lines. But instead of saying that, so I'm going to type this, guys, ps-ef pipe grep smon, because I know every running instance has an smon. So if I do that, that is simple. Give me just 2 processes, and I can take. If I have 10 databases, I'll have 10 processes there. 10 smons, in other words. You can see here, that's smon, and that's the database name. Are we there, people?
Yeah.
Guys, this is so important for your practice as a DBA. If you don't take notes on this, I don't know how. You're not going to read this in any book again. It's not going to be anywhere. This is the practical thing. So everybody must know this command. Everybody write that down for background processes, right? If you didn't, or if you haven't, or if you were not remembering.
So this is to check the background process?
Yep. No, this is to check running instances on your database. If you want to find out which database is running, this is the big key here, London. ps-ef pipe grep, right? Will show, it's a command to show you processes running on the machine. But I don't want to see all the processes. I'm a DBA. I want to know if there's a database running. So I would simply type aura underscore or smon. If I type smon, it simply shows me the smons that are running and the database instance name by it. Oops. Where are we? Where did my thing run to? Just 1 second, guys. Okay. Guys, it's very important, guys, you wrap your head around this because this is it. Listen, grep, you could put smon, you could put aura, you could put anything. Now for the listener, I want to find out which listener is running. It's going to be the exact same command. So you can write that down, guys. To find out what listeners are running, I'm going to type this command. This is the command. Same command, but instead of smon, I'm going to type LSNR. Remember LSNR CTL? It is a utility running. So if I type that and I hit enter, watch that, guys. I want you guys to watch this carefully. Let me do it again. If I type that and I hit enter, hey, watch. There's a listener called listener, and there's a listener called BT1. I don't worry about that word inherit. I don't even know what it means, but it's always there. That's how I check to see if there's a listener running. You get that, K? Hey, is there a listener on this machine? ps-ef pipe grep LSNR. And who knows why I use LSNR? Yes, listener control utility. Oh, watch this. Watch this, Lambert. Watch this. Watch this. Watch this, Lambert. I can use this. I can use this. Watch that. Everybody watch. I can change it, and I put TNS. It's going to give me the same thing because it will find this word. See, this is the actual program running inside the bin directory. That's it. So write that LSNR or you type TNS LR. What if I just put TNS? Same thing. You can just put word TNS.
I ran that same command as root And it didn't give me what I wanted to see.
Yeah. Root does not have privilege to Oracle Home, sir. That's why source.bash profile. Root does not have the .bash profile. Remember, all this running, you're dealing with this because your .bash profile is configured. Right. We started right from the beginning with the .bash profile. Very important. So root cannot create a database. If root type DBCA, nothing will happen. Yeah, because Oracle Home is not in the path of root.bash profile. If you want root to do that, go put all that .bash profile stuff inside root.bash profile. The root can do that. But it's a no, you never ever do that. Okay, guys, very, very important. That's it. And with that, TNS names, because that's the listener. That's how you do the listener. I want to check. I want to create a configure TNS name to connect to the database. As you configure one call what? In that assignment. BT something.
The listener was BT.
And the TNS name was?
So we should do a connection called BT.
Okay. So it's the same thing. Net Manager, guys. I go to Net Manager. That thing should come up in a second. I go to Net Manager, click on local, click on service naming. Service naming, very, very important. And I highlight there and I click the plus. And what did I say should be? BT. I could just type BT or BT caps, it doesn't matter, it's not case sensitive. And I go next. And I go next, host name, the machine that I'm running this thing on. What is mine called again, for crying out loud? Test 30, lowercase. So I come here and I do test 30, and the port that I used was 1523. I got that port must match 1523. Then I go next, and the service name can be anything. As a matter of fact, service name, no, this one cannot be anything. This one should be an Oracle service name, is normally the global database name. For mine is class T. And the for connection, guys, let me just pick dedicated for the fun of it now. And I pick dedicated. And I go next. And I can test that bad boy. It's always going to say, once it says, look at that, user ID Scott, account is locked. I know it is working. It's just that account is locked. So I don't have to go any further. You see that? I know it's working. So I'll just click OK. I tested it. It connected, but just to a bad account. So I'm going to do finish. And then I go here and I do save network. Come back here. Now do Control-C, close that window. TNS, no. As a matter of fact, I think I have a shortcut to go to my, yes, I have a shortcut to go to that folder. Just TNS. I have my shortcut already, not your own. You're going to make your own. My shortcut, when I type TNS, it takes me to the SQLnet files. There are 3 files, listener.ora, tnsname.ora, which one? What's the third file, guys? Nope. Nope. Which are the 3 files we configure when we configure SQLnet? Everybody, you should know this by your fingertips, on your fingertips by now. Which are the 3 files? You saw that those 3 files yesterday. What chapter was it? What page, Lambert? You are right there in your book. Page 143. Yes. Page 151. Everyone go to page 151. Yeah. SQLnet.ora. Guys, everyone's going to write this down in their textbook right now, in their exercise book right now, that there are 3 files, page 151. There are 3 critical files involved in OracleNet. Everybody go to that page for me and write that and number those files like I'm doing in my textbook. 3 files. You must know their names and their functions, what they do. So when we configure SQLnet K, we deal with 3 files. And number 1 is the listener.ora. Number 2, hey, no, hold on. So number 1, listener, located only on the database server. That's important, write that there. The listener is located only. What's your notebook? Please, don't be lazy, you gotta write. Yeah, open that, take that book, get
Prof, it's under which subtitle?
TLS.
Prof, please, under which subtitle is it?
This is
Under which subtitle is it?
Oracle Network. What do you use? What do you use? Okay. What are we studying now?
File names and the CNS admin environment.
But what's the big topic? Oracle Net. Oracle Network configuration. Oracle Net. Oracle SQL Net. Oracle Network. You can call it anyone, but it's Oracle Net, Oracle Network, Oracle SQL Net. That's what we're studying. It involves 3 files. The list number 1, listener.ora. You did not highlight your book. You gotta highlight that book because you're not gonna sell it. Even if you sell it for $1, nobody's gonna buy after this. So you gotta write in it. So, number 1, listener.ora, found where? On the database server, located in the database server. So, I want to put bullets, located on Oracle server. The second bullet should be used for starting the, contains listener parameters. Contain the listener, rather say, contain listener config parameters. Yeah, we'll talk about the listener.ora. There's a file called listener.ora. We're talking about that file. Contains the listener configuration parameters. Often you just hear it say config. They don't keep calling the word configuration. So, okay, contains listener configuration parameters. E.g., what are the parameters? E.g., protocol, address, and ports. And ports, P-O-R-T-S, or port number, whatever, if you want to call it port number. So guys, that file contains those. No, port, and then also write this, at Oracle Home. Oracle Home must be specified inside also. So that is information inside that file, guys. If you look inside the listener.ora, which maybe I should show you guys again. Everybody watch here. Let me do more on the listener.ora. Guys, see here. It contains, I told you guys that the Oracle Home. It contains, what was the second thing I gave? Port. Oh, that was number 3. Port, protocol, and the address is yes, the address is actually all those things, which is the protocol, the host name, and the port number. Also write, guys, also write host name, host, host name.
Quick question. Yesterday we did the listener using VI.
We did the TNS names more.
Okay.
Uh-huh.
And that was like
Doing manually.
Yeah, manually. We copied
Now copy an existing entry and you change it.
So why is it that because I was trying to do it over here, so when I hit the space bar and then like it gets to 100%, it opens the new user home.
Then you simply did cut. That was no more. That was no VI. See, like here?
I did more.
Yeah, if you do more, because the file is long. When you do more, it shows the first page. So the first page of mine is 74% of the entire file. If I hit space bar, it does the last 33. Listen, more does this. You have this big document.
One page at a time.
Yes, you have this big document. When you do more, it shows you that page. You hit space bar, it shows you that page. Hit space bar, it shows you the next page.
Okay, so my main question was, okay, what if you wanted to copy and paste and then edit the text?
More, you do VI, not more. It's more that does that percent thing. More is only to see with your eyes. VI, you go change stuff. So if you need to change, is VI. You want to read, you just want to see the file, more. Or cat. Okay, hey guys, the next thing inside the listener.ora is this. Global DB name. Everybody write that one. There's a global DB name, there's an Oracle home, there's a seed name. The Oracle seed name must be inside. Okay? Okay. Then, that was number one file. When they tell you configure SQLnet, listener must be on the server listening for the database. Then the next bullet I want to write under there is this. We said use to configure the listener, right? Then write a note below there that the listener listens to incoming requests in the database. What does the listener do? It listens to incoming requests. The listener's job is to listen to incoming requests from clients. Remember? Listens to incoming requests from clients and starts and spins off server processes. We saw that yesterday. Write that in that note again. It also spins off server processes. That thing starts off. Without the listener, we'll have no server processes. It's important to know that, yes. So that's it about the listener. Number two file. Just 1 second, guys. It's happening. Okay, just let it go. Still running now. It's going to run for the next 30 minutes or 20 minutes. Hey, guys, what's the number two file for SQLnet? tnsnames.ora. Everybody write that down. And this 1K, used by clients to connect to this database. That's the main thing. Used by clients to connect to a database or a database instance. Maybe you want to put that. i.e., used for name resolution, database name resolution. So right at the end, say i.e., used by clients to connect to the database.
I.e. used for database.
Used for name resolution. Use that for name resolution. So guys, then if you really want to put another bullet, typically located on the client side. Typically located on the client side or client machine. It's on the client. It doesn't have to be on the database server. It will be on the database server if only there are clients on the database server connecting to the database. You see that? If you don't have any clients on the database server, you don't need it there. So, but every client machine will have a TNS name file. Yeah. So client side, this particular TNS name is on the client side. Listener on the server side. Two different files. Then guys, another thing about it, also write another bullet, used by clients or used by user processes to locate the database listener. It is this file that will point us to the database listener that's going to spin off server processes for us.
We're talking about SQL.
We're talking about TNS names. The TNS names is used by user processes to locate the DB listener. You have to keep spelling the word database. Whenever I say database, just write DB.
Used by user processes.
To locate the database listener. For database, just write DB. Don't keep spelling it out and spend energy typing that same word. Okay. Number 3, SQLnet or SQLnet.ora. SQLnet.ora. Right there, optional means we don't really need that file. Most of, I'll say 90% of the time we don't need that file. Optional. Then after that, right, may exist, may. Listen, it's a may. May exist on server side or client side. Or both. May exist. May. For that particular file, most of the time, Linden will don't need that guy. But if we need it, we can create it. If we need it, there's a folder in there called sample. You could just take the sample thing and you edit it and you put it in there. What else about that? Oh, the biggest thing, put another bullet on that SQLnet.ora. Typically used for troubleshooting. As a matter of fact, when they ask you to use that file, 80% of the time that they want you to use the file because they want to troubleshoot connectivity. Typically used for troubleshooting connectivity to the database. If you're having connection issues, then they'll tell you to they'll give you some parameters to put inside the SQLnet.ora file.
So it's typically used for troubleshooting connectivity to the database.
Yes, or database connectivity. So like you have a user, right, and they're trying to connect, you go configure TNS name on your machine. But for some reason, it's failing and failing. It means you cannot get to the database. If you open a ticket with Oracle, it will tell you, okay, enter these things in the SQLnet.ora and then try the connection and then get the trace files and let's see what it says. So, guys, next thing, where is the location of these Oracle SQLnet files? Oracle home. Now, I want to write just below there, nice little red pen. SQLnet files are located in Oracle home /network/admin. They are located in that. You know them because, guys, most of the time you will install Oracle, you will have to edit some files, you will have to do stuff. And located in Oracle Home /admin, no, /network/admin. At this point, if it tell you that, you just write OH. You should remember that Oracle Home is OH.
All these files or that file?
All these files, all the 3 SQLnet files. If you go to any machine, find out where Oracle Home is. You go to Oracle Home, there's going to be network, there's going to be admin. You go see those files and you can look at them. And before you change them anytime, it's good to make a backup copy. Never just go change a file like that. Even your SP file, you need to change it, make sure you back it up. As a DBA, you never want to lose a file because you change the file, right? Then things are not working. They don't know what to do. So always keep a copy. So they've changed it, you start the database, it doesn't start, you can use the old one and start it back. Then you troubleshoot again before you come back. Because you don't want to increase downtime because of your error. So that, in reality, maps almost all I want you guys to know in this chapter of SQLnet. It's one of the smallest chapters in the book, but very, very important because you need this to connect to a database. For you to connect, especially clients, you have to configure this thing. So with that, let me see. We are going to move a little bit forward. Hey, good night.
Thank you.
All right. So we're going to do, you guys had an exercise there to do. For those who want to do it, good. If you don't want to do it, that's fine.
If I started the exercise, like I got stuck somewhere.
You didn't, did you put a ticket in the group?
No, it was like almost time for class, so I just
Okay. Now, there's some other thing. Let me see. What about shared servers? Use the Oracle shared server architecture. Let me see. Then to really need to know about this. Dun, dun, dun. Want to see here. I will just highlight a few lines. Hold on, guys. Let me look for my. Where is my pen? Just a second. Let me look for my Apple pen. Where are you? Where are you? I'm supposed to have it somewhere around here. Oh, right here. Okay. I would, let me see here. I want you guys to read this shared server architecture section when you have time. But no, in our current level, we don't need this. Yes, I'll just skip. Skippy, 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 skip. We don't need that. We don't need that. And we are going to go to chapter 4. Let me see, what is chapter 4 all about? Oh, we're doing chapter 4 now, right?
Yeah.
Oops, sorry. We're going to go to chapter 5. Let's all go look at chapter 5. It is from there that the real Oracle that you need really, really begins. From that chapter, any person who's not doing this assignment, ha ha ha. Yeah. I don't know what to tell you. And by the way, before you get there, we also have the textbook. Turn to page 164. Let's just see. Let me see if I can go back on mine too. If you're on that page 164, there's an exercise 4-2. Set up a shared server environment. They tell us how to set up that shared server environment. I'd like to go back there and just look at that exercise instead of reading that whole section. How do you set up that thing? Just a second. Let me see. Let me try to go back to my thing. Where is that? BT97. Classroom. And me. Textbook 11G, chapter 4. Okay. Let me see if I could go. I want to see that exercise. Important exercise. Yep, right here. 4-2. Guys, let's look at this exercise 4-2. By the way, when do you guys think the use of shared servers is needed? When do we use shared servers? Do you know that, Lyndon? When and why should we use shared servers? Okay, it's all in this chapter. I would like you to read that. That chapter 4, part of it. When and how do we use that? Hey guys, I just tell you guys, just in case you ever ask, you use shared servers when you figure out or when you know that your database is going to have a high number of concurrent connections. I want everybody to write that down. We're not going to talk about it anywhere else. When do we use shared servers? Typically when you know or when your database would be having a very high number of concurrent connections. For example, above 50 concurrent connections or above 50. Then it's time to think of configuring shared servers. When do we use shared servers?
When you know when your database will have a high number.
Yeah, when you know that, don't put when you know that your database may or shall be having a very high number of concurrent connections, or just a very high, number of concurrent connections. What are concurrent connections? 50 people, 100 people connected at the same time. That's concurrent. If you know that you're going to have a high number, and the rule of thumb, guys, maybe you want to write it down, rule of thumb. The rule of thumb is that you use the rule of thumb is that you turn on shared servers if you're going to have over 50 concurrent connections to your database. We'll just make that a rule of thumb. So that's one rule of thumb that you should have. 50 people connected at the same time. You guys get the point? They don't mean that 50 connected in a day. 1, then 2, then 3, no. 50 are all ganged up on that database. You want to turn on shared servers. You want to turn on shared servers at that point. Then the next question is, how do we turn on shared servers? So they can ask you that at an interview. Then they say, oops, how do we turn on shared servers? And that is what that exercise is on page 164. Exercise 4-2. If you look at this, guys, let's read that exercise together and pretend to do it. In this exercise, or rather the exercise says, set up a shared server environment. In this exercise, which continues from step 21 of exercise 4-1. No, 4-1 is what I ask you guys to do. So if you didn't do it, ha ha ha. There was that exercise has over 21 steps. You will configure the shared server and prove that it is working. Number 1. So guys, Lambert, if you need to set that shared server stuff, one of the first things you do is you set the dispatchers and the shared server's parameters and register with the listener as follows. So how do you set that? Everybody look at that. It says alter system set dispatchers equals protocol equals TCP, dispatchers equals 2, scope equals memory. So that's a dynamic parameter. You see that? Then the next thing you do, alter system set shared servers equals 3, scope equals memory. Alter system register. So this is how you set the dispatchers and the shared servers and register them to the listener.
When you do scope equals memory, that means.
Oh, no. Did you say scope equals memory?
Yeah, that's what it
Okay,
is.
yeah, that's dynamic. Yeah, that means dynamic.
It's going to be just for that instance.
Yeah, just for that. In this case, it's an example that they're doing. So the one that when we finish, it doesn't stay. Yes. Yeah, just for the instance. So when we shut down, things will go back to normal. Otherwise, you could have said scope equals both. Get the point? Are you looking at that, Emma? Okay. Then number 2, confirm that the dispatchers and shared servers have started by querying the $$ processes. Everybody highlight me that $$ process. Look for processes named S 000, S 00123D. So guys, server processes, their names begin with S, then some series of zeros. And dispatchers' names begin with a D. Select program from processes, order by program. You guys see that statement there? That's how I write a typical SQL statement. This is a cool exercise, but it's a continuation from the other exercise. You said you got stuck on that one? Yeah. Okay. From an operating system prompt, confirm that the dispatchers are registered. So you could do that using the listener control utility services new list. Then connect through the listener and confirm that the connection is through the shared servers. So because now they're doing, guys, watch how the guy does the connection. He's using apt. So they must have created a connect string called new. And probably I believe it's in the other exercise. Yes, it's in 4-1. Then select da. Okay, this query will show the dispatcher to which your session is connected and the shared server process that is executing your query. Tidy up the environment and clean up by returning the original configurations. Alter system set local listener, blah, 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 blah. That's how you tidy up the thing. Then say stop the listener on set TNS name admin variable, because we had done that TNS name admin variable somewhere. So, hey guys, good exercise. I'll do that exercise. I'll do those 2 exercises and master the listener, and then that's it. But the rest of that chapter, any other thing there is too high for the level of this class, so don't bother much about what is there. That was chapter 4, and we're done with that chapter. Please I'll still beg you guys, do the exercises. If you have trouble, put it in the group, and we'll try to understand. Because one thing you guys have to also know is this. You have to learn to read and understand and execute. Because after this class, you'll be on your own. So you have to start learning here to read, then do something, then it's wrong, then we'll say, no, you did not understand what was written, this is what was asked, and this is how you do it. You don't want me or us to do it, and then the day you have to go to the real job, you cannot do it. So you must, everybody here must be experimental. You cannot destroy anything on that machine. You have snapshots. Just do it, type, and think, and type, and force yourself to think. Now, we're going to the very, very important thing, storage. Guys, listen. We install Oracle, no, we configure the Linux machine, edit our .bash profile. We know how to source the .bash profile in 3 different ways. Then we install Oracle. We unzip Oracle, install it. After we install Oracle, we run those 2 scripts, root.sh and ora inc root.sh. Everyone must know what those scripts do. Then after we did that, we use DBCA to create our database. Created the data. No, after we did installation, we configure the listener. And we know how to configure and stop and start the listener. We all know that. Then after we finish that, we use DBCA to create the database. The only thing I did, I gave you guys exercise to do it manually, but I know nobody did it. But by the time you understand Linux enough, it will be easier to do that, probably later on. Then, after we created the database, that's chapter 3 or so. No, chapter 2. Chapter 3, we'll learn how to manage the instance. Managing the instance means changing the parameters of the instance, like shared pool, SGA target, memory target, and processes, and all that. You could change any parameter now. You can even add dispatchers and add server processes, as we just saw. But guys, if you don't do the exercises, you will not remember. The only way you remember this thing is doing those exercises. Then we did TNS name. No, we did Oracle Net, which is also called Oracle Network or Oracle SQL Net or Oracle Net 8. They had like 4 different names. We did that, and we saw that it deals with 3 critical files: listener.ora, tnsname.ora, and sqlnet.ora. Listener.ora used to configure the listener. tnsname.ora is just used to connect the client to the listener. And SQLnet, we use that to do some troubleshooting and some other few things, but it's optional. Now, guys, big time, we're going now to database storage. Oracle storage is the current topic. So, and what is storage, guys? When you go for this company, everything we've done so far, right? We are not storing the company's data. We just have Oracle running. The data dictionary is in there. That's all that we have. By the way, I haven't missed. We talked about the data dictionary. 3 groups of tables. User underscore, all underscore, DBA underscore. Then dynamic tables used to monitor the database. Being updated constantly. Created only when you start an instance. Okay. So we've done all of that. So let's now move to a bigger new topic, storage. If we need our company to store data in this database, this is where we are. We must think about storage. So what is this storage all about, everyone? Whenever they mention storage to your ears, the first thing you want to remember about storage is table space. And every table space must contain at least 1 data file. A table space must contain at least 1 data file. So guys, this whole chapter is about table spaces. We'll learn how to manage table spaces, create and manage table spaces. We're going to learn how to handle space management in table spaces. It's very, very important. So let's zoom in. chapter 5. We're now on page 172. If you have your book with you, which I encourage everybody does have a real book with them. In this chapter, guys, overview of table spaces and data files. I will not read every line in this book because I recommend that you guys go home and read. But I'll read some few things and we spend more time doing like what we did this evening, the practical side. So what's this overview here, guys? Data is stored logically. Everybody highlight for me the first 2 lines on that section. That data is stored logically in segments. And the typical segment is the table. And physically in data files. The table space entity abstracts the two. What does that mean? One table space can contain many segments and be made up of many data files. There is no direct relationship between a segment and a data file. Don't worry about that. All of that, you'll not see that anywhere else. The data files can exist as files in a file system. That is very important to know. Or on automatic storage management devices. We're going to study something as we go along called ASM, automatic storage management. It's the same like hard drives, but managed by Oracle. Oracle data storage model. Let's see a few things we need to know here. Don't really have to know too much on this section here, apart from that diagram. There's a whole lot of junk there at the top, which for now, you guys may really don't mean much to you, but I'll just skip to some things that would make much more sense. If you, let me see, should I just jump to that diagram? Just hold on. Okay, this Oracle data storage model, guys, just highlight for me the first line. The separation of logical from physical storage is a necessary part of the relational database paradigm. The relational paradigm states that, what does it state? As a matter of fact, let me highlight that. The relational paradigm.
Programmers should address only logical structure.
And let the database
manage the mapping to physical structure.
Yes. This means that physical storage can be reorganized, or the whole database moved to completely different hardware and operating system, and the application will not be aware. Figure 5-1 shows the Oracle storage model. So we're going to go look at that Oracle storage model in that thing as an entity relationship diagram. Guys, everybody, I wanted to just write here where it says entity relationship diagram, write ERD. It's a big word that we're going to see later on. Entity relationship diagrams, they are called ERDs. With the logical structures to the left and physical blah, 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 blah. And as a matter of fact, that diagram is explained down here, that there is one relationship drawn in dotted line. Oops. A many-to-many relationship between segments and data files. Let's go here. Here, guys. And I believe I've explained this diagram before, right? Somewhere. And when I explained this, what I said right at that time was this, guy, that whenever you see this, this means many. Yeah. And whenever you see this, 1 and only 1. So here it's like this. Many data files can belong to one table space. You guys see that? That's what this line here means. Many data files can belong to one table space. That's what this represents. That's what this represents. You see the many on the data files. But now watch this one. This is another many. This one here, this is also many. Oops. Let me change, go back to red. So this is many. And what does that particular line there means? That simply means, yes. In other words, this is in relational speak or language. They say many to many. And this one up here was 1 to many. Or, hold on, let me put many, oops. This one here will be many to 1. Many dash to 1. Everybody should write this in their notes. Everybody should. Okay, you want to write this. I don't want to, I'm not going to come back to this almost never ever. Do you know, as we're studying Oracle, right? There are some people who go to classes like this just to study this. This is called data modeling. This is a data model or an ERD. Let me see the name at the bottom. What did they call it?
The Oracle storage model.
Oracle storage model. And this thing is called a, no, we don't call it data model. Yes. Yes. As a matter of fact, it's called data model. An ERD. This is a typical ERD. Entity relationships. Each of those blocks is called an entity. An entity is simply a thing. These are things related to one another. Guys, we're not going to come back to this because this is not our main study, course of study, but you need to know this to understand how databases work. When they design a database, this is where all database designs begin. They begin on a diagram like this. But they use it now to explain to us the difference between the logical part of the database and the physical part of the database. In other words, if I open my computer right now, I'm going to see data files. And data files, one data file is made up of many operating system blocks. You guys see that here? And many operating system blocks will make a one Oracle block. So everything on this diagram here is many to one or many to many. Or sometimes they could call it one to many or many to one. Depends what direction you're coming from. So guys, everybody take note. Did everybody scribble these things here? Scribble me that word many to many. Many to many to one, many to many. Guys, you gotta write these things and remember them. This is part of data modeling. They call this thing a data model. Or you could go study, right? You go take a course in data modeling and become like a data model designer. So you go to a company, they have no database, and you say, okay, we need to design a database for your company. You start to gather this information and you create these entities and you link them up. Then they give them to a DBA, DBA will convert them to tables and foreign and primary keys. So, for example, if you look at this diagram here, where it says data files, we have data file ID, for example. we go to table space, there's going to be table space ID, and there's going to be data file ID in there. So this table will be related through data files. But anyway, we're going to do that in class when we design our database. Hopefully, after we finish this section, we'll start doing projects. Okay, let's move on. Forget that diagram. Let's go to something else. As a matter of fact, go back to the page just before this. Let me just highlight something about table spaces. Table spaces. Everyone, swing to that page. The table space entity resolves to many-to-many relationships between segments and data files. So look at that diagram again, then you try to understand what that says. Everybody go back to the diagram on the next page and understand that statement. Look at table space here. So a table space, one table space can have many data files, and one table space can have many segments. So inside the same table space, you can have data segment, you can have an index segment inside the same table space. That's the typical thing that will be in there. It's very important to take note. Okay. Then let's go to, let me go back to that other page where we were. Yeah, this page, page 173. Let's look under there for segments. I just want to skip this, and it's not too important for us as DBAs, this particular section. Highlight for me the first line for segment. The segment entity represents any database object that stores data and therefore requires space in the table space. Your typical segment, guys, see here, they give us a typical segment. Your typical segment is a table. But there are other segment types, notably index segment, undo segment. See, index segment chapter 7, undo segment chapter 8. Any segment can exist only in one table space. But the table space can be spread across, all the files making up the table space. This means that the table sizes are not subject to any limitations imposed by the environment on the maximum file size. Okay, we don't have to get into all that. Let's go down to Oracle block, next section. The Oracle block is the basic unit of I/O for the database. Guys, smallest unit of storage, basic unit of input-output in the database is the Oracle block. We did that from the beginning. Everybody here should know, everybody in this class should know how to draw that diagram back there over and over and over, that Oracle block. If you haven't drawn that thing 5 times, then I don't know. I don't know how I can tell you again about it. But we're going to see that diagram from now. We're going to see that Oracle block till the end. Performance tuning, backup and recovery is the Oracle block. Data files are formatted into Oracle blocks, which are consecutively numbered. So guys, every Oracle block has a number. Every Oracle block has a block ID. Very, very important. The size of the Oracle blocks is fixed for a table space. And I'm going to highlight that. Everybody highlight that in your textbook, that the size of an Oracle block is fixed for a table space. Generally speaking, it is the same for all tables in the database. The default, this is it here. If I ask you about your default block size, the default for block size is 8K. A row might be only a couple of hundred bytes, and so there could be many rows stored in one block. Here, K. One block can, one block can have many. One block can have many rows. But when the session wants a row, the block will be read from disk into the buffer cache. That's something we know already, right? Similarly, if just one column of a row of one row has been changed in the database buffer cache, the DB writer will eventually write the whole block back into the data file. You guys are catching that? That's stuff we know already. That's junior for us. From which it came overwriting the previous version. The size of the Oracle block can range from 2 to 16K. But I know it's a little bit bigger than that, and we're going to practice that in class. In Linux, oh, and 32K in some operating systems. Okay, it's written there. So guys, everybody, K, write that down in your notebook. You're slipping. Guys, the size of the Oracle block can range from 2 to 16K on Linux or Windows, but it can also be 32K on some systems. The block size is controlled by the parameter DB block size. As a matter of fact, we saw this already in class. This can never be changed after the database creation because it is used to format data files that make up the system table space. So let me ask you, why is it that the default block size cannot be changed after you create a database? What's the answer?
Because it's used to format the data files.
No.
Make up the system table space.
Yes, system table space is a big key. So you cannot change it after. After you make your database and it's running, you cannot go in and change that default block size anymore. If it becomes apparent later that the block size is inappropriate, the only course of action is to do what? Create a new database. Everybody highlight that. And transfer everything to it. The block is uniquely identified by its number within a data file.
How do you transfer everything from
Export, import. We're going to do that. Managing space, one block at a time, would be crippling, or would be a crippling task. So blocks are grouped into extents. See, we studied that already. So why do we have extents, if you're ever asked? Why do we have extents according to that note? That's the answer right there. Why are extents needed? Yes, for space management. Because if we need to manage the blocks alone, one by one, it will be crippling. We spend all our time, Oracle spend all this time managing blocks. So they make in such a way that Oracle instead manages but extends. And an extend is made up of blocks. An extend, guys, look at the answer for extend here, which I hope everybody has that one. What is an extend?
Set of consecutively numbered Oracle blocks
Yep.
in a data file.
We saw somewhere that it's a set of contiguous blocks. Every segment will consist of one or more extents, consecutively numbered. These extents may be in any and all of the data files that make up the table space. An extent can be identified from either the dimension of a segment or the dimension of a data file. Every segment is in one file, starting at a certain Oracle number block. Okay, that's it about that guy. Let's go now talk about data files. This is just a summary of what we did, isn't it, guy? Huh? Talking about the blocks. Table, Tables, you talk about storage, which is data files and table spaces. A data file is physically made up of a number of operating system blocks. How data files and operating system blocks are structured is entirely dependent on the operating system. Some file systems have well-known limitations and are therefore not widely used for modern systems. For example, old MS-DOS FAT32, blah, 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 blah. Most data files will be installed on a file system with no practical limits, such as NTFS. Don't worry about that. The alternative to file systems, data files are raw. Okay. Don't worry about that whole thing. Let's go down the Oracle operating system block. Don't need to, that other thing of it doesn't really matter. Is
The basic unit I.
yes, for file system. So see, there's operating system block, the basic unit of I/O. While for Oracle, the basic unit of I/O is the Oracle block. A process might want to read only one byte from disk, but the I/O system will have to read an operating system block. The operating system block size is configurable for some file systems. We don't have to get through all of that. Let me see where I am in my thing here. Yeah, let's go to segment. Don't read that whole thing. We don't care about operating system block at this point. Segments, extends, and blocks. We did this already a month ago. A month ago we did this, but because it's so important, we will just zoom through this again. So guys, number one thing is data is stored in segments. Then the data dictionary view DBA segment describes every segment in the database. So guys, there is a data dictionary table or view called DBA segments. So guess what? So there'll be DBA data files. There'll be DBA extents. See, once you know that architecture, you can start to put many things in place. Okay, the query shows a segment type. Let's go to that query. Everybody on the next page. 175. 175. What does it say? Select segment type. Count 1 from DBA segment. Group by. I want you guys to see that statement. Group by segment type. Then see the next one. Order by segment type. Guys, SQL statements are just like pure English and logic. Select segment type. So we're going to see name all segment types. Then the next column was count 1. Is count the total number of each segment from DBA segments. After you select them, group them by segment type. In other words, right? If there are tables, put all tables together, put all indexes together, put that together. That's the group by. Get the point? Group by requires sorting. This is when the temp table space is used. Or the guys, where does sorting take place in your database? For everything we've studied so far. PGA. Take place in the PGA. If the PGA is not big enough, it's going to move and take place in the temp table space. That's something we did. Okay. Next, order by. Listen, group. Take all tables, put them together. Order by. Arrange according to segment type. So look at the statement, everybody. Look at the output. The output is actually this whole thing here. That's a segment type. So Let me see how many segment types we got here. This whole thing here, guys, is segment types. So there's cluster, index, index partition, lob partition, lob index, lob segment, a nested table, rollback table. Table, guys, is the same as data segment. You saw data segment somewhere at the beginning of the class? That's what table is. So I put IE data segment. Then number 10, table partition. Number 11, undo type 2. And I think that's it. So there are 11 rows. So there are 11 records, 11 types of segments, in other words, that we can see here in this particular database. Hey guys, remember that these are types of segments. This from there to here, we could call it 11 types of segments. We saw just a couple before. But notice here, the temp segment is not shown. You notice that? Yeah, they will not be shown inside there. But later on, we're going to see that temp, there's a temp segment. But it's not listed in here. So, people, let's zoom to the next place. In brief, let's start to define them here again, guys. So here, if you ever look and still curious to know, these are types of segments. Number 1, table. And always remember, table is also called data segment. What is that? What are tables? Hope everybody here knows what a table is. And look at that. These are heap structure tables that contain rows of data. Heap structure. Everybody underline me that word heap structure. You're going to catch that later on. Not just any kind of table, a heap structure table. Heap. The default table types are called heap tables. Even though a typical segment is a table segment, never forget that the table is not the same as the segment, and that there are more complex table organizations that use other segment types. That's true, like the partition table. We want to see that. So now, number 2, the index. What are index segments? They are sorted list of key values, each with a pointer to a row ID. Everybody write that down for your index segment. What is an index segment? We're going to write that sorted list of key values, each with a pointer. And that pointer is actually called the row ID. And number 3, type 2 undo. We wouldn't spend much time on any again. We're going to just zoom by. What's the type 2 undo? These are undo segments. No one refers to them as type 2 undo segments. But these guys store pre-changed versions of data that are necessary for providing transactional integrity. And transactional integrity has to do with a couple of things. Yep, rollback, read consistency, and isolation. Now, what is the rollback? What is now the rollback segment? People, it is now, this rollback segment is now actually called, let me see. Yeah, it's called undo. When you have rollback, I want a way to write undo above it. That will be a number 4. Let's say, on that number 4, rollback segments should not be used in a normal running database, blah, blah, introduced in that. There will always be one rollback segment that protects the transactions used to create a database. You don't have to worry about that. This is necessary because blah, 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 blah. Okay, don't worry about that. Just leave rollback segment. Or we need to, as a matter of fact, I know rollback segments are really, really not used again. So we won't see any question on that for sure, I know. Next thing that we want to look at is the number 5, table partition. What is that? What is a table partition? A table can be divided into many partitions. If this is done, the partitions will be individual segments. And the partition table itself will not be a segment. Okay. Hey guys, the partition table into different partitions, each partition becomes a segment. But the name of that table itself is no longer a segment. But the table has been broken down into little segments for easy manageability. And they say that table exists only as the sum of the total partitions. Each table partition of a heap table is itself structured as a heap table. I'm going to highlight that. These segments can be in different table spaces, blah, 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 blah. Then let's see the next one, and we're almost done with these things. Number 6, index partition. What is an index partition? Highlight me that first line there. An index will, by default, be in one segment, but indexes can also be partitioned. If you are partitioning your tables, you will usually partition the indexes on those tables as well. That was not a big topic of this, but they just come here. We are doing table spaces. Let me see. As a matter of fact, I don't see these things in any exam. Let's just hang on this one and see. Lob segment. What is a lob segment? Hang here just so that you guys can at least learn start to get used to these names. If a column is defined as a large object data type, so guys, there's something called large object. That LOB stands for large object. Okay, if a column is defined as a large object data type, then only a pointer is stored in the table itself. A pointer to any entry in a separate segment where the column data actually resides. Okay, let's highlight that. Lobs can have indexes. So you see that word now, they change it now, bring it back out, lobs. See those things can have indexes built on them for rapid access to data within the large object. Hey guys, let's talk about this large object just without reading that stupid book. Large object. What's a large object? Guys, a large object, right, can simply be like a picture in a database. The picture is not actually stored inside Oracle, it's stored in the operating system. But there will be an Oracle table that has a pointer that points to the location where the picture is stored. That's what all they're telling us here. What about a cluster? What's a cluster? A cluster, everyone, highlight for me the first line that says a cluster is a segment that can contain several tables. That's it. It's simply many tables put together, like a cluster of bushes made of many trees. What about a nested table? If a column of a table is defined as a user-defined object type that itself has columns, then the column can be stored in its own segment as a nested table. Hey, nested table is more like a column in a table kind of stores its own data within itself somehow. But it's nested. Like a bird makes a nest. Look at that, the bird is inside. Not much. We're not going to deal too much with that. So let's go to the real thing and go create our table spaces, guys. Let's say you guys read this. Ha ha ha. Lucky if any person would even turn to the page. Guys, every segment is comprised of one extent. When a segment is created, Oracle will allocate an initial extent to it in whatever table space is defined. That's for information. Eventually, as data is entered, that extent will fill. Oracle will then allocate a second extent in the same table space, but not necessarily in the same data file. If you know that a segment is going to need more space, you can manually allocate an extent. An extent. Show how to identify blah 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 blah. Hey guys, let's see the statement down here. Look at this statement and see if it makes any sense to us. Don't worry, we're getting to the practical side. If you guys like the practical side better than the reading, you need to read to know the theory. You need both. You need both of them. But not necessarily, but you guys should be reading this maybe when you wake up early in the morning or sometime you're really more fresh. But if you guys can do most of the reading, we can be in class and we're doing a lot of hands-on and hands-on and hands-on and hands-on. Extents. Let me just, we saw a data dictionary table called DBA segments, right? Same as there's DBA extents. So, I don't really care. So let's look at our first table that they create here. Even though the goal of this chapter is table spaces. Hey guys, everybody see how a table is created. Create table, HR. Everybody watch this. Create table, HR dot new tab, C1 date. Whenever I see a statement like this, HR, in this particular case, is the owner. This one, guys, is the owner. And this one here is table. As a matter of fact, let me call it segment name. The segment is, typically there will be tables and indexes. Segment name. And those segments can be a table, can be an index, can be a cluster. So, take note of that. Okay, you know what? Let me even kill you guys with this SQL. They write a nice complex SQL statement here, but I'm going to skip that table. We don't really need that. But then go to the next page.
Who is the owner going to be the
HR? They're creating a table under the user HR. This statement here, guys, just telling us how you can allocate and extend to a table. I can add and extend. So add storage to a table. Don't worry about this. We're going to deal with that later on. Let's go to let's go down. I'll just highlight some other words here. I want you guys to see the words. There is something that's DBA underscore data files. You want to know all the data files in your database? Credit DBA underscore data files. All the extents, DBA extents. All the segments, DBA segments. And all the tables, DBA tables. That's all I want you to catch on this page, and we don't care about the rest. And we go to the next page. As a matter of fact, this whole section is supposed to skip. Let's go to file storage. Data files can exist in 4 devices. This now is important. Where do we keep data files? Data files can exist in 4 devices, people. It's okay. The big question here is, where are those data files located? Where can we keep them? Number one is a local file system. And number 2, it can be in a cluster file system. Number 3 can be in a raw device or an ASM disk group. We're going to number those. Those are the 4. They say 4 devices. There are 4 devices. Your database finished creating? Okay. So, everybody, what is local file system? Who knows what a local file system is? Let's start right from there. When it says local file system in your computer, what does that mean? Yo, lady, please let's focus. I'm talking about things I'm not going to talk about again, and these are important. What is a local file system? Because that is just basic computers. They expect that you know already. It's not Oracle. But there are things that if you don't know them, you go to work, you within 2 days you wonder where you came from. What's a local? When you say something is local, what does that mean? If something local means within. Not something from outside, something within. So what a local file system means, it's a file system on the computer. Local, that the computer came with, not folders. Whenever you hear the word file system, typically think from the bottom, from the hard drives, local hard drives. This comes before folders come inside. So we talk about a file system every time, people. They mean your computer storage, your computer drives where you can store information. So the first most common place to keep data files is in the local file system. Yes, the disk that contains the directories. And we studied OFA, we saw Aura Data, we saw Oracle Home, Oracle Base, all of that. They are folders. The local hard drives, the local storage devices on the machine. That's where you should start. Local means they came with the machine. Once you bought the machine, it came with your C drives and all those drives inside. Now, guys, everybody highlight this for me. Local file system. These are the simplest data files. They exist as normal operating system files in a directory structure on disk, directly accessible to the computer running the instance. Yep, like you say, okay, they have directories, but local with your machine. They come with it. I mean, they came with it, no one has changed anything on it. On a PC running Windows or Linux, this could be internally, no, this could be internal IDEs or SATA drives. Let me ask you guys now, who knows what a SATA drive is? The rest of the class, I want you guys to pay attention. I want you all to pay attention, people. Nobody should be doing something else except you're writing something about the class. Because we're going, these are the important things about storage. If you don't understand this, the rest of, as we go further, you'll just get lost. This section, right, this topic, chapter 5, this is where the real oracle begins. Please, nobody want to miss anything here. You don't want to. This, remember, we are taking this class. We are not starting from Computer 101. It's a high-level course that assumes that you know a whole lot of things already. You know the word file system. You know the word directory. They assume that already. So, but I know most of you are not used to those terms. That's why I'm saying pay attention. You don't pay attention here, you're going to be lost. Files on a file local system. When you buy your computer, it comes with hard drives. That's the beginning of your local file system. But the SATA drive and an IDE drive. Guys, I want you guys to look at those words. Those are words you want to get used to them. Right. Who knows what an IDE is or a SATA is? Okay, can I explain to them what an IDE drive is and what you guys listen to the difference between IDE and a SATA drive. Listen, this thing is called a drive. That's a hard drive, but there are different types. Okay. The SATA hard drive connects. The connections are different. And the IDE hard drive, I don't have them anymore. They don't have, yes, they have more. Yes, it has just pins. It doesn't have this thing. SATA hard drive, IDE hard drive is just the design of the drive that makes it different. But they've moved away from IDE and they make these ones now. So you hear the word SATA hard drive. They talk of hard drive that look like this. After class, you can come pick here and you look and you see what they look like. It's good to have an idea, guys. You get into computers. You have to know these things all around. So that you go somewhere they don't speak and you're like somebody who just came from the village. Oh, they discover that, they just say, okay, we need somebody else. Because your job will be to take care of the company's data. And you don't know some real basic things, they will not take a chance with you. Not a chance. Okay. On more sophisticated hardware, there could be, guys, look at another type, SCSI. As a matter of fact, I'm going to highlight this in a much bigger pen. So these are some important words I really want you guys to catch. So there's internal IDE, SATA drives, and there's SCSI disk. And then there is external drives. An external drive is usually just something like this. Or they're just hard drive, but they're connected to the machine. Okay? And SCSI hard drives are used by servers. Big servers don't use SATA hard drives, those regular, they use SCSIs. You're going to hear that word, and I want you guys to see how the word is spelled. It's pronounced SCSI. If you care, you write it down. You don't care, don't write it down. Someday you'll see it someplace, and you act like you never ever saw it before. Okay, hey, just talking. Files on a clustered file system. What's, guys, the next thing is, what is a clustered file system? Just good to have an idea. A clustered file system is usually created on external disk. I want you guys to hear that. Created on external disk, mounted concurrently on more than one computer. Normally, guys, you may, I really have to bring an example here. They'll have a box on which they put many of these hard drives. There could be 10, 20, 100. They're all inside one big box, and they just put them in there. And the box is standing on its own, they hook it up to power, to electricity. Then there are cables from that box that they can hook on servers. Then those servers will be using those hard drives. That is what they call a clustered file system. And one clustered file system can be used by many, many servers, so many computers. Okay. The clustered file system mediates access to the disk from processes running on all computers in the cluster. Okay, we don't have to worry much about that. Let's move down a little bit. Then we'll see another thing called a raw device. The next thing is, what is a raw device? Raw devices. It is possible to create data files on disk with no file system. Guys, these are disks with no file system at all. That's what a raw device is. This is still supported, but is really only a historical anomaly. What is a historical anomaly? What is an anomaly, guys, in English? When you see something is an anomaly, what does that mean in English? You don't know? Write down that word, add that to your vocabulary. That's what you should know. Write down that word, guys. Really write it somewhere, put a question sign, and you're going to find out more what it means. Guys, write down that word, and you're going to find out what it means. What is an anomaly?
There's something wrong.
Different from the norm. Different from the norm.
Yes. No, it's not that something is wrong. It's just that it's not the normal thing. It's not the usual thing. Something a little bit unusual. It's not usually. It's not commonly used. In other words, historical anomaly. It's something in the past. In the bad old days, before clustered file system or ASM existed, raw devices were the only way to implement a parallel server database. Parallel server itself was replaced by rack. So don't use parallel server anymore. But guys, you hear of raw devices, right? It just typically they are drives that are not formatted. And Oracle will kind of still use them to store data. But they are not formatted for the operating system. No. Okay. But as you see, they are a historical anomaly. Not used anymore.
Is that like what happened with this one? Like they had to split in the hard drive and
no, I don't think so. But raw devices, you have some. If you see very expensive cameras, when they take a picture, the picture is raw. Then they take a picture to the lab, they can change the picture to anything they want. They can change the colors, they can do a whole lot with it. So professionals take raw pictures. They're not formatted. Files on ASM devices. Let's talk about the ASM here, guys. ASM, for this particular one, ASM is automatic storage management. A facility introduced with 10G, an alternative file system based data file storage. Chapter 20. What chapter are we in now? 5. So we're going to deal with this in chapter 20. ASM is, Oracle recommends that we use ASM for our data files. That is the recommended one. So, guys, I hate this. I hate this little section, but okay, let's see the next thing. ASM is tested in detail in second. Okay, so guys, they even test this in just in OCP. So we're not going to deal with it now. We're going to see ASM, but it's above the scope of your class. But we will do it when we get to our boot camp, because by the time we go to boot camp, the assumption is you have your OCA So we're doing higher Oracle at that point. Let's go to the next page, 179. Logical volume. We're going to talk about mirroring and striping here. I think that's the first time we'll talk about that in class. And for this particular one, when we get to it, I would really like everybody to just write something down. First paragraph on page 179. The logical volume can be much larger than any of the physical volumes of which it is composed. Guys, pay attention to that. We're talking about a logical volume. Logical means it doesn't exist on its own. There are some physical volumes. You put many physical volumes together to make a logical volume. Furthermore, the logical volume can be created with characteristics that exploit the performance and safety potential of using multiple physical disks. The characteristics are, guys, what are the characteristics? Now we are going to study a couple of things. Striping, mirroring. What is striping? As a matter of fact, striping. What is striping? By the time we finish this section, the big word I want everyone to learn is the word striping. So there's striping, there's mirroring. Okay, yeah, those are the two big words, striping and mirroring. When we finish this, I'm going to stop, give you guys 5 minutes. Everybody's going to write this down. Everybody must know what striping is. Striping data across, you get a straight line. Striping data across multiple physical volumes gives huge performance gains. In principle, if a file is distributed across 2 disks, it should be possible to read it in half the time it will normally take, if it were on 1 disk. Performance will improve geometrically in proportion to the number of disks assigned to the logical volume. Okay. And what is mirroring? Mirroring provides safety. So mirroring provides safety. And what does striping do? Gives huge performance gains. If a logical volume consists of 2 or more physical volumes, then every operating system block written to one volume can be written simultaneously to the other volumes. Let me come back here. If one copy is damaged, the logical volume manager will read the other. Woohoo! Isn't that cool? If there are more than 2 physical volumes, a higher degree of mirroring becomes possible, providing fault tolerance in the event of multiple disk failure. So I'll stop right there, and then we're going to fix something here. We're going to talk about a couple of things. And in your book, if you're highlighting like mine, I wanted to go back and circle some words. We're going to circle the word striping there at the top. Then we're going to circle gives huge performance gains. Then you come down, you circle the word mirroring. Provides safety. Oops, I highlighted the wrong word down here. And you come further down, Come further down, you circle me the word providing fault tolerance in the event of multiple disk failure. Then I'll stop right there, and we are going to talk about this disk, about this whole thing. This is a little bit complex. Let me see. Do you want to talk about RAID? I know there's talk about RAID in this book somewhere. Okay. I'm going to just give you guys, let me go to my notebook. Let me go to the note, and then I give you what I want you guys to write for now. This part of what we're talking about now, there are things that are known by these things are not, the DBA has to have a big overview, but they are actually done by the system analyst. No, system, not system analyst. How do you call guys who take care of computers? System administrators. This is done by system administrators. That's what I'm trying to say. Yes. So guys, what we're talking about, write that little topic there. Everybody, I want you to write in your notebook. RAID. RAID. We're talking about RAID. And RAID stands for let me get a black pen. Redundant. Let's stop it from spinning. Oh. RAID stands for this, guys. Redundant array of inexpensive disk. That's what RAID stands for. Redundant array of inexpensive disk. Redundant array of inexpensive disk. That's what it stands for. Now, there are different levels of RAID. So, I'll write here different levels of RAID. Number one. Number one is RAID zero. RAID 0. And RAID 0 is striping. That striping that we just saw. RAID 0, striping. And striping, in reality, is multiple at least 2 disks. Striped. And why do they do this? When they do this, this provides huge performance gains. This huge provides huge performance. So why do we strive for performance? That's the main thing. Huge performance gains. We strive for one reason, for performance. So we do RAID 1. It's like this, guys. What they do is this. They could take many hard drives, or at least 2, and they combine them with software or hardware, and they're linked together, and the computer sees them as one. So when you write something so it sees this as one drive. So when you write something, the thing is spread between the 2. Part is written here, part is written here. 50-50. So in theory, something that you're supposed to write for 10 minutes, you can write it in 5 minutes. Or half is here and half is here. Get the point? Performance gain. You stripe. Take hard drive, strike them together, like you merge them, fuse them together, they become one. But they still have individual spindles to write. So instead of just having one pin that is writing, like this one, you have 2 pins writing the same data. So half goes here, half goes on another pin. So it goes faster. So you strive for performance, and that is RAID 1. For system administrators, you will call that RAID 1. Then number 2 type of RAID would be RAID 1. No, that was RAID 0, excuse me. RAID 1. And for RAID 1, anyway, I want you, RAID 1, also known as, so that's what RAID 0 is also known as striping. RAID 1, aka mirroring. I should write those words in really big, nice colors. Mirror. Mirroring. Mirroring. Mirroring, for this one, let me see, multiple hard drives. Okay, mirroring. In case of 2 hard drives, remember guys, hard drives are called disk. In case of 2 hard drives, they are configured such that data is written to now such that, excuse me, such that, just a second, such that data is written to each, such that data is, how can I put this? How can I put this? Now, such that data is written simultaneously to each. Yes. Simultaneously to each. i.e., data is duplicated, i.e., data is duplicated. For, what's the big reason of this one? This one is not performance anymore. This one is for safety. No, let me write safety. I use the word safety instead of security. Should be the word safety. Or sometimes you call that availability. Safety or availability. So,
Can you do striping and mirroring at the same time?
yes, that is rate 10, or rate 5. Hey, guys, for mirroring is like this. The system is set up in such a way that if data is written here, the same data is written here. So if this hard drive dies, the system, computer is still running, because now they're reading the data from here. So that is RAID 1, mirroring. The other one was striping. Striping means they take many hard drives, merge them together, they become like one hard drive. So the data is being written by many pins. You see that? You want to read data, many pins are reading the data also. So writing and reading become faster when you stripe. But if one of the hard drive dies, you lost part of your data, so your data is gone. But when you do mirroring, it may be slow, but you cannot lose your data. What do you think a bank would prefer? Just the speed or the mirroring? If things get worse, they want the mirroring. They won't care about that. They don't want to lose any money. But in ideal situations, in the world of today, most companies go striping, mirroring. This is striped, this is striped. What is written here is written here. Yes, based on both worlds. So, for us DBAs, why are we studying this? They're going to ask you, where would you keep your data files? Where would you keep your control files? On a mirror disk or a striped disk? Get the point? That's why this is important for us. Very, very important for us. Because when you design a real production database, where should your data files be? Where should your regular files be? Do you care about the striping, the mirroring, or which one? But most companies cannot afford both. Both is expensive. Having both, they actually do this. They'll take minimum 5 hard drives and they stripe them. When they stripe 5 hard drives minimum, they stripe them now. That is called RAID 5. When you use RAID 5, now it gets to a point where you have each of these things here is 10 terabytes. So if I stripe 5 of them, that's 50 terabytes. You guys get that? And the speed of 5 now. Then with higher technology, you can create what they call parity in here. Instead of having 5, let's just say I was doing this 4. Instead of having 40 terabytes, I might end up with 30 or 25 terabytes. And the other section is kept for parity. The other section is kept in such a way that whatever is written on all these other disks, pieces of it are written in the parity section. So that if this one hard drive dies right now, the database, everything will continue to run. But the sysadmin will have a message that a hard drive went bad. Because once that one gets, I'm talking on the Stripe system, once that one goes bad, the system will intelligently make up for that one from the parity and still continue to run. Then we can buy a brand new hard drive, come quickly, put it back in place without shutdown. And the system will reconstitute the data that was here and build this one back up. When that happens, I call that hot swapping. Means you can hot swap a file, a disk. You can remove a disk while the system is running, and the system doesn't go down. You put a new disk, and the system will rebuild itself from parity. So that one alone kind of has mirroring and striping together, but you lose space. Get the point? So what they do right now is they do that. Often they use like 5 hard drives, and they mirror not. They do the same thing, then they mirror the two together. So whatever is written here is written on the other one, but they're exactly the same. And there's hot swapping possible. To the point where if you make many disks, you can even hot swap up to 2, 3, 4 disks, and the system is still running. But that is very expensive. But that is what any real company with a real database, they spend the money for that, to do that. And that is not RAID 1, or that is RAID 1 and 2 combined. When you combine RAID 1 and 2, you have RAID 10. So number 3, there is now something called RAID 1 plus 0. RAID 1 plus 0 equals RAID 10. Very important. So you know it is mirroring and striping. So we should remember that. So RAID 1 is mirroring. And this guy is striping. Any question on this RAID stuff before we move on? We're going to see later. For those who are interested, I can send you some document to read when you have time. But there's RAID 5. We didn't talk about it. There's RAID 3. There's RAID 1, RAID 0, 1, 3, and 5. RAID 5, minimum 2 disks until part is created for that parity. But once you use, like, you start to go with higher rates, then you're losing space for the parity, which for most companies, that's okay. Okay, because it just guarantees that you cannot lose data. Get the point? So now, as a DBA, let me ask you guys. You're creating a database and you have the choice between, you have RAID 0, RAID 1. We know. What's the big advantage of now? RAID 0, RAID 0. At least this, which one does the backup thing? RAID 1. RAID 1, striping. Why did I write that word? I want to write that word up there in big nice red. We'll have red 0. Actually make that striping 101. I want to put that striping really nice big blue. Striping, guys. Whenever you hear red 0, you want to say striping. You hear red 1, mirroring. So the big thing here is this, guys. Multiple disk provides huge performance gains. Then mirroring, guys, one of the disadvantages of mirroring is you lose space, right? So you have 2 terabyte, 1 terabyte, 1 terabyte, but you're only using 1 terabyte. So maybe write it somewhere on this thing. Only use half of the space. I'll write it here, guys. Here, half of the space is wasted for mirroring. Yeah, it's wasted because you're not using it. You know you actually have 4 terabyte, but you can only use 2. So it's wasted. So that's the only drawback. Looking at this now, guys, red 0, striping, speed. But you have plenty of space. Where should I put my, is it necessary to put the control files on red 0? Or, listen, if you have red 0, red 1, I need to put the control files somewhere. Do you worry about speed for the control files, or you worry about the safety of them? Already we have 2-3 copies.
Oh yeah, striping.
Because already, right? Yeah. We make multiple copies of the control file because they are backups of each other, so we don't really care. So for that, we don't really care where they are. But for data files, typically, guys, for data files, you want your data files to have the fastest speed possible, especially the undo. Undo is used heavily. Heavily used. Okay. So the other big word that you will hear a lot about mirroring is fault tolerance. You see what we said, safety? Also right there, it's fault tolerance. For, safety, availability, or i.e. fault tolerance, not all. Guys, why? The big word you hear all the time is fault tolerance. That's why we use mirroring or red one. So apart from that, let's move on. Let's go. Exam tip: ASM can store only data files, not the binaries. Everybody, let's go down. I wanted to create something. What time is it? Whoa! I gotta skip something. If I wanted to create table spaces today before we go home. Yes, must create table spaces. Must. Everybody, I want to explain anything that's not in this book again right now. Everybody, let's highlight the next line. ASM is a logical volume manager designed for Oracle database files. The definition of database file is broad. Apart from the true database files, control files, online regional files, and data and log files and data files, ASM can also store backup files, archive logs, and data pump files. All these files will be detailed in later chapters. It cannot be used for Oracle Home. Yep. As a matter of fact, this even a stock in here, that's an Oracle exam question. Oracle Home cannot be stored in ASM. Everyone just highlight that line, just hang on it. When you do ASM, then you will understand more. Then you highlight that exam tip down there, very important. Then there's an exercise, investigate the database storage structures. Hey guys, you guys look here on that exercise. Everybody, I think I'll start to get to exercise and we'll look at them. Connect to database as user system. We all know how to connect as user system in this class. Okay. Number 2, determine the name and size of control files. To ever do that, the only thing I want to remember is $$ control file. That will give me, if I select from there, it gives me the names of my control files and their locations. Okay, select name, block size, times file size, blocks, bytes, whatever. Then determine the names and size of the online radio log files. I query $$ log file. Everybody should mark and know those tables. Mark and know those tables, guys. $$ log files, $$ control files. What about data files before we get there? Can somebody tell me? If I want to know the names of my data files, what could be the data dictionary, the dynamic performance table? $$ data file. Thank you. Let's go on the next page. You guys should start to see how these things are named. $$ data file. And the temporary files is $$ temp files. You guys see that? You gotta pay attention to those names and the architecture we did. As a matter of fact, one of these days we're gonna come to class. I'm gonna give everybody a big piece of paper and we're all gonna reproduce a diagram like that one above K up there. Everybody should be able to draw that diagram. Guys, one of the best ways of learning is drawing. You gotta draw. Maybe I'm gonna give you guys some information and you kind of understand how it's important, especially if you're finding it difficult to remember things. Draw them. Either like cartoons or whatever. Hey guys, next one. Create and manage table spaces. Yay, now it's time for work. Table spaces. What are table spaces? Table spaces are repositories for schema data, including the data dictionary that we saw is inside the table space, guys, which is the sys schema. The data dictionary is owned by the sys schema. All databases must have the system. Guys, see that one there? Everybody highlight that. Every database must have a system table space and sysops table space, and a temporary table space and an undo table space. How many of them are mentioned there? Number 1, system. Number 2, sysops. Everybody's going to highlight that. And number 3, temporary. I'll actually put number 3 to be undo, and I'll put temporary like on. Temporary, you can actually exist. The 3 mandatory table spaces for database to start up are the undo, system, and sysops. Can start up even when there's no temporary table space. Temporary table space are used only for sorting. These 4 will usually have been created. Subsequently, guys, as a DBA, subsequently, you create your own people. These 4, in other words, K, those 4 mentioned, right, come with your database. Those 4, they come with your database. Then you must create additional table spaces for user data and possibly additional table spaces for undo and temp. Table space creation. That's our thing right now, guys. So let me look here. Everybody, crank up your machine. We have 20 more minutes. Everybody start up your database, log in there, and the rest, we're just going to do. Oh, I thought I could finish that chapter today. I think I get diverse too much. I have to stop that from this class. Stop going to talk about rate when we shouldn't be talking about it. Everybody, let's create a table space. Everyone, log into your machine and you start up the data, fire up your database, go to OEM. Everybody. Everyone. So I'll be doing the same exact thing right now on mine. So I exit there and I'll be going to my database, which is here. Yep. Is that my database? Oh, it doesn't look like it. Why do I have a 20 there? Oracle code test 30. Let me check something here. Something doesn't look right. Maybe I'm connected to Barbara's own machine. $23? What is that? Okay, doesn't matter. So, people, I'm inside my database. The first I need to go to OEM. Everybody should know how to get to their OEM. Everyone. So, how do I go to my OEM? How do I get the address of my OEM if I forgot? Huh?
Using your URL.
Yep, using URL. If I forget URL, I could type emctl. I do the status thing, DB console, and I should have that address if I forgot it. And there it comes. I'll just copy that, and it's because of my port. So I'll copy that thing, and I go to my browser. I'm actually in mine, right? I think it's still running. Maybe I do it all over just so you guys don't get confused. If I go to my Google browser or Chrome, I'm going to change that machine name to my IP address, 192.168.1.30. Hit enter, and it should log me in, guys. It should log me in. So go to your browser, you enter that, you should be in, everyone. What are you doing? You are not there. Do what we're doing. You see, if look at my screen, you gotta be looking at the screen. I just got that URL. If you were not looking, you won't even know where I am. No, you should now know how to do that. Remember, every day come and say log into your OEM every day. That's what I want. Go into your, look at your book to find out how to go to your OEM.
I've done my MCTL status DB console. I've gone.
So copy the URL and go to your browser. And did you type the EMCTL? EMCTL.
Oh, it's this right here.
And that's something I've stressed over and over. Everybody write this down in your book. Write this down in your note. Write this down in your note. Everybody should know how to go to the OEM like in a heartbeat. EMCTL status DB console. It will give you that address if you forgot it. But it's something that you should not forget if you remember the name of your machine. Did you log in to the thing already? So get the address and log in. Why don't you make this thing small so you can open the other thing? Now your thing is covering your whole machine. Is your database running? Is your listener running? Did you ever connect to it before? Well, then I don't know what's wrong. Either try to start it and stop it again or something.
Is it this one? Am I typing in this one?
Hmm?
Am I typing this one?
Yeah, that's your address.
From the
You
same
copy that address and take it to your browser.
when we put it on the browser and then it gives us this site can be reached, what else did you say what to do to get?
Put your change the name of the machine to your
I
IP.
changed it to the IP 192.168.1.34.
And it says what? Try to ping that IP address. Go to your machine and do ping on that IP address and see if you can access it. That address you copy, put it in here. Change that host name, T40, to your IP address. Just that name. Change it to your IP address. You see mine up here. So once you do that, you should be in. Guys, you copy that IP address like I did on mine here. You copy it, and you copy just to EM. You could copy the whole thing, it doesn't matter. But the machine name will be changed to the IP address. And after this, I really want everybody to document how to do this. Because we cannot come to this every day we're on the same thing now. EMCTL status DB console. If it tells you that DB console is not running, then you have to start it. Is yours running?
I can't figure out my. Oh, mine is running, but I can't.
If it's running, the IP address is the same. 192.168.1.40. You also be .40. That's why we named that machine with with that T or test 40 or T40.
Prof, the username was sys, right?
Yes.
Password sys.
Or system, sys or system, anyone would work. So once you have that address, if you want to use that inside your browser, you must change that IP address like I've done here, or change that name to an IP address. Just the name, don't change anything else. 192.168.1. Then your number, the number that you have after your machine name. .40, .30, .28, whatever.
And then after that is 1158.
No, you copy that from your machine.
Yeah.
Okay, if that's what it is, then that's what it is. Because some people have a different port. That is a port number. That number can be different for other people. It doesn't have to be 1158.
I typed it in and I got this. It says your connection is not private.
Not private.
Huh?
It says not private.
So look at it, Zeus and
Get the
see.
press accept. Press more options and then place accept.
But we have the two of them down that way. Is yours working, K?
When I put in the sys and then put in the password,
It says what?
this site can
Give what?
this site can be reached. And then I try to use the back button.
Yes. It did it. You are on the right track. Just do refresh. Just do refresh. Don't do no back button. And copy that, put it in a different tab.
I get to change the test 38 to IP address. You get to change that test 38.
I have to do Control V and Control C faster.
Yeah, I just like doing it like that.
But you got to learn to do it the right way. And that's real unprofessional.
I've been posting in my
You're going to be
side.
able to just do this thing without a. Yeah, because
Posting stays
you
on
blocked
side.
it, probably you blocked it before. Because from seeing it here, it was, where was that? Here. It was going. Just you blocked it. So as it says, not secure means it was accepted.
That's right. So the place when I went to allow, it says that
The one I do, I did say that one that really,
So that's what I'm copy.
yeah.
So I'm changing the.
You have to force it to accept this thing. The thing is, you have you've asked it to block that thing somewhere. Wait, somewhere you're supposed to just do accept right from the beginning. But if you didn't, you actually do now your browser is now blocking it. Open a different browser. What browser are you using? Okay, try to use this. Try to use this one now. Let's see. Why do we have lock on there twice? Maybe just try to.
Prof.
Yeah.
Mine says that Firefox is already running, but it's not responding. So I don't know. I've tried a couple of times.
Now, because you're trying to
Like
run it
1, 2.
inside you're running it inside the Linux machine. Copy it and run it in open
Yeah.
open Chrome. Don't run it in Firefox.
Okay.
Open it. Oh, you run it from
My
the,
normal Chrome. From my normal Chrome.
No. You're running where on your phone?
No, I'm asking whether I should run it on the normal Chrome from my machine.
No, not on your. Cannot run in your machine. You are connected to any desk, right?
Yes.
Run it in that same machine in any desk. Open Chrome in that machine in any desk. Open Chrome inside that any desk machine. Then it should work. You put it there, your address is 30. So once you put it there, you simply change that address to 192.168.1.30. Just that machine name. Then it should work. Remember, you guys come here every day, tell everybody, start up your go to your, everybody should go to their OEM. So you guys have not been checking that. Did you get in? Sys.
Yeah, I'm gonna go look for the command to fix it.
Yeah, do sys or system sys, it doesn't matter. If you do sys, then you change that to a cd. What's the error with yours?
Yeah, password is 6.
So what? Hers is not working.
The error's right there.
What are you troubleshooting it? Or what?
Yeah.
Okay, yours. Okay, you are in yours now.
This field.
Okay, the thing. Yes, it's not done correctly. Cannot find the file that get this thing to. This is your database.
Okay, it says the site.
This is nothing. You have something is missing. When your database creation finish, did you see the the window that comes up?
Do access DBA. It's like there's a drop down. I said there's a drop down.
that you see
Was it this right here?
Yeah.
But
So to give you something.
yeah, that's what it gave me, but it didn't when I clicked it and went to it didn't work.
Database creation is supposed to give you that if it succeeded, but it did not succeed for sure. Does you get that script? Tell you to run it to reveal this or
yeah, username and
or
password.
create a new database or something. Once it gives that error something not found, it's because yeah, your creation did not end like it was supposed to. Yeah, so it's not seeing a certain file. So your database creation failed.
I'm using the CSS now.
What's the error? Read the error. Yeah. So your password is invalid. That is not an error. You're entering the password that is not the one you gave. So that is. So what do? Figure out the password. Remember you created a database on there. You type the password with your hands. I did not. When you create a database, you put a password. What password are you giving it? Because those are things that, Emma, you get there, you think for yourself, I entered this password, it didn't work. Why? Am I entering the wrong password? Because that's what it is, you're entering the wrong password. What user are you using? Was your password uppercase or lowercase? That's a question you ask yourself.
I've tried all this one.
Then your password was probably lowercase or uppercase. Try one and try the other one, it should work.
I've tried all the two CSS, even use DBA.
Try system. But the thing is that password is case sensitive. So however you typed it, did you connect Barbara?
Not yet, Prof.
What are you inside the Google Chrome of that machine where you where you connected us in any desk?
No, wait, when I was about to connect to that, it said the site cannot be reached. And then
remember, it should be Chrome inside that machine.
yeah, I clicked on it. It said the site cannot.
It must work. Or have to log in and find out. So you're in? Are you in? Did you get in? Try to start that thing, let me see. When you try to start it, what does it do? Start living console. Did you write that thing down? What about you? Did you? Okay, you are in. Okay, you are in, you are in. No. Type system up there. Let's do that system. At the top. Username.
The database, yeah.
Lowercase, 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 lowercase system. You only type
But
this.
if it's indicating that
No. Type system. Password is sys. And click login. Type that password in caps. That might be your problem. Yeah. Your password, when we did that thing, you entered your password in caps. That's it. That's why. So you just have to remember that. So You're in. Are you in?
No, no.
It says non-existent network card.
It's a non-existent network card. Okay. In. So for those who are in, maybe the rest is going to watch us. We're going to do what we're supposed to do. So when you go home, you practice and do the exercise in the book. Everyone's going to follow me. People, let's all watch me so that you guys go home and do this. Everybody should watch me. Then when you go home, we'll figure out this OEM stuff. If you have trouble getting your OEM to work, we'll fix that later on. So Emma, you're in. Remember, the thing is your password is in caps. I believe even that sysown is in caps. So everybody watch. If you are on this screen here, I would not even follow the book. I think that book is a little bit older than what we have. So I'm going to create a table space. Let me just look at the book and see if there's any specific step. I want you guys to go home and follow this. Yes, page 192, people. So I'm right here. I'm going to click on, watch all the tabs we have. There is home, performance, availability, server, schema, data movement, and software support. But we're going to go under server. I click on server. You see here storage. This is what we are studying right now, storage. And the second one is table spaces. I'm going to click on table spaces. Then it gives me all my table spaces that I have. Please, you all follow me so you can do it to later a dozen times. So here, guys, 1, 2, 3, 4, 5, 6. I have 6 table spaces, but I don't care. I'll click here on create to the far right here. So do create. Then it comes here name, the name of my table space. What do they want me to call it? The book wants us to call one new TS. So I type new TS. That's new table space. Then I'm going to leave that alone. And I want you guys to watch extent management. We know what an extent is. Multiple blocks put together, contiguous set of blocks. Local, dictionary. So there are 2 ways to manage your extents. They can be locally managed or dictionary managed. But Oracle wants us to do locally managed. Directory managed is an old thing. We don't have to do that anymore. Then the type of table space, people. A permanent table space is one that when data goes inside, it stays forever. Temporary table space, we know they're used just for sorting. And undo table space, used for undo because of read consistency, rollback, and blah, blah, blah. We remember that. Then, so we're going to do permanent for now. And status, a table space can be read-write, read-only, or it can be offline. But guys, we'll leave all of that alone. And then we are going to do data files, come below. We must add a data file. So I'll click add, guys. And you come here, ask me what name of the data file that I want. What's the name of the data file? By tradition, the name of the data file should be the same as the name of the table space. Then 01, DBF. So I'm going to call my new TS01. I'll call it like that. Dot DBF. DBF is the extension of all data files. Make them .dbf. Then guys, look at the path. It used this path because when we created a database, we chose that path before. So if you did pick U03, it will be U03, whatever you want. But if you want to change it, you can change it right here. And to change this, normally you can change, it's better to change just like that number, just the number or something. Because all the paths are the same. U01, U02, U03, 4, 5. Okay? Then guys, how big is my data file? I won't use that. I'll use 2 megabytes so that it creates fast. Then reuse means if I'm creating this thing, if that data file is there already, Oracle will write the data file. It's going to use it. It's not going to fail and tell me, oh, data file exists already. That's why you pick reuse if you have to, but you don't have to pick it all the time. Storage, automatically extend. Woohoo! This is auto extend. When Oracle uses my 2 megabyte, add another 2 megabyte. So my data file will be growing. Is that kilobyte? Thank you. So I could pick megabyte right there. So if it uses that, add more. Then I'll have 4. If it uses that, add more. It will keep adding and adding and adding and adding by 2, 2, 2, 2, 2. Okay? Then I can go here. That's storage. Maximum size, unlimited. So this data file can grow until it uses all the space in my hard drive. You get the point? But sometimes you might say you're a DBA. I want that. I don't want this file to be ever more than 1 gigabyte or 1 terabyte. So if it gets there, it stops. It cannot grow bigger. You could limit that if you think you were moving that file from one place to another point. If the file is too big, it's more harder to move it. So there are times where you could do that. Then I do continue. I want you guys to watch. So I've done that, and now I want to click on storage. What's under storage? Extend and location. Automatic. Means this. How big are my extents? Oracle will automatically decide how big they are. But if I don't care, or if I care, I might say uniform size. I don't want them to be more than, I don't want an extent to be more than 10 kilobytes. Or you can even do that, 10 megabytes. I don't want any extent to be more than, let me just say 1 megabyte. Means this, all extents of 1 megabyte. And Oracle actually adds space considering that megabyte, that extent. Because an extent is a certain number of blocks, remember? So if you divide that by 8K, you know how many blocks will be in one extent. You get the point? But most of the time, Oracle these days tells us, don't worry about making it a uniform size. Just let Oracle manage the extent sizing for you. So the recommendation today is to do bada bing, this guy. But for now, let me just leave that. Segment space management automatic. Objects in the table space automatically manage their free space. It offers high performance for free space management. So leave that automatic. You want to do it manually? Oh yeah, you're on your own. Oracle actually wants us to make things automatic these days. We may have automatic driving cars. Compression, no compression. We want the files to be compressed. So guys, when you guys go home, you're doing this, read every line. You cannot sit in class and read everything. Try to read them and understand them. Logging. You remember I talked about the log writing, right? If I pick here, you guys watch here, logging, yes. That means whatever data is going inside this table space, archive logs, radio logs will produce. But if I don't care to reproduce archive logs or radio logs, I can say no logging. When you say no logging, whatever you're dumping in there, right? If the system crashes, there's no recovery, nothing, because there are no radio log files. Okay. There are times when we do that, when we're loading a lot of data from somewhere. We have the data here. We're loading it. We want to load it fast, we turn off logging. Because if it fails, we'll delete it and we'll just load it again. But if it is online, like banking or shopping, you don't want to do that. You want to have that logging. Okay? So that's it. Then I'll do this. Shh. Everybody watch this very important step. Emma, you're not watching. It's very important step. Show SQL. This is the script that I've just generated. The only thing new DBAs would like this and want you to use this is that you use it to generate the scripts. But as an old DBA, you don't have to use this thing. So I'm starting that. Let me go put that inside. Just a second. Let me look for my own hands-on thing, and I show you guys what I'll do with that script. Yes. So right here, I'm going to save that thing here. What's today? July what? 2nd? Oh my God, time is flying. This is the script that I just got from out of there. That's how long the script is. Create small file table space. When you go reading, you're going to find out that table space can be small file or big file. So it says create small file table space, new TS, data file, and that's the data file and its size. Watch that, data file. It gave the location of the data file and the name that I gave and the size. Reuse simply means if that file exists, override it. Then auto extend on next 2 MB. If it uses the full file at 2 MB, automatically extend the file. Then maximum size 1 GB. So that file cannot be bigger than 1 GB. Logging, yes. Radio logs will be produced. Extend management will be local, and uniform size would be 1 MB, which that is a bad idea. We want to make it auto. Then segment space management automatic, and that is the end of the script. You put a semicolon. That's how you end the thing. So now if I copy the script, guys, and I do my SQL plus, either sys or system, it doesn't matter. System says that's my password, and I run that script, it should work. So if I do this now in that database, I hope I'm in my own database. Yes. If I do this, I'm logged in and I run that script, there's a chance that it will work. Woohoo! Invalid option, create table space. Can somebody tell me? Oh, segment space management. Segment, oh. There should be a space there for segment space. And I paste that bad boy. It should say table space created. That's how you create table spaces. And a database can have hundreds, dozens of table spaces, as many as the application needs. Okay? So we're getting now to that point where we'll be doing this. Then that same table space that I just created, let me show you guys again. While here, let me do return. I want to change it so I can create it back with a different name. I could have done, let me call this underscore test new test xxxxx. I don't care. Let me just give it a strange, stupid name. Then I go to data file. Where's the data file thing? I go edit data file. I want to name that data file the same stupid way. I just want to do it again so you guys see how it works. So I come here. If I click OK, it will create that table space. So if I click OK, and look at that. Table space is created already. That's the other one I did at the top. You guys see that? So I created 2 table spaces like click, click, click. But as a DBA, you always use by the script. Because that script, with the script, it goes faster. With the script, if you do it in dev, you're going to test, you just take the same script. You go into production, the same script. Yes, those we're going together. Not together.
Huh?
So we went together.
Why?
I don't have my car. I'm going to. So, guys, everybody play with this as many times as you can. You destroy nothing. The only thing you want to start, maybe take a snapshot of your machine. Okay? So, like here, if I want to drop that table space, as you guys can see here, let me click on that one that I just did, and I do delete. It asks me, once a table space has been dropped, the object, delete associated data files. If I click yes. Did I click yes? Yep, it's gone. That's it. So guys, you guys have a lot to do for the weekend. Everybody.
So the exercise you want us to do this?
Yes, do the exercise on. Yeah, the exercise is right there. Just follow that whole thing, and then do your own. Play with it as much as you can. This is let me see. Create table space is page. You have the textbook now. That will be on page 180.
Okay.
Then after that, there's an exercise behind there. But do as much as you can. Guys, you cannot destroy anything. Just play with this thing and go down and back and forth.
And just hit table and okay, I'll go to the table.
Yep.
Prof, please post the chapter 5 for us.
Excuse me?
Please paste chapter 5 for
Oh,
us.
yes. We do that right now. So that's it, guys. It's pretty simple. It is only practice and time. Just play with this back and forth, then you understand how it works. It's nothing great. But as a DBA, let me tell you, as a DBA, go to work. One of the first things to ask you is you're creating table spaces, you're creating users, you're changing users' passwords. So after we do this create table spaces, we're going to end this on Thursday. Monday, we're going to chapter 6, which is creating users. Then after we create users, then we'll start to create tables and put data in them. Once we know how to create tables and put data, and then we'll go to backup and recovery. From backup and recovery, we'll go to performance tuning, and the class is almost ending. That's it about Oracle. It's not too much. But the only thing, people, is to keep your hands steady on that keyboard. You gotta play with it over and over and over and over, and then you find it so easy you will not believe it. So till Thursday, but we'll send you guys a quiz for Thursday. We'll send quizzes out, guys. Take time to do those quizzes, because those quizzes are what you will find in the Oracle exam. So you want to start practicing them now over and over. See, if I were you guys doing this class, I would do every quiz like 3 times over. I would do every exercise like 2, 3, 4 times. I roll my machine back and forth. Guys, it is 4 months of school. Think, 4 months of school, and you can look for a job for 90,000. 4 months of class. Then you don't take it serious. Then you're dreaming. If you work in McDonald's, before you make 50,000, you may work there like 10 years. If you decide to go to college now, to go do computer science, even when you finish that school, you don't make half of the money somebody who finished this class is making. You will not. If you go to University of Maryland, you pay, by the time you graduate, you've paid over $100,000 in school fees. You're not going to earn. You come out, it'll be hard to find a job. You're not going to find a job for 50,000. My daughter went to school. She did computer science. Graduated with cum laude, whatever they call it. She could not find a job. Her first job was 45,000 because she refused to take my class. By the time she decided to come back and take my class, you know what happened? She was married. She had a child. She had a husband. She was busy. Until today, she never finished the class. But my brother-in-law who lived with me, we didn't have money to go to college, took the class. His first job was 98,000. His first job. Within like 6 months, he was doing 2 jobs. No college degree. None. No college degree. Until my daughter came and saw it and asked me, Dad, is that true? I said, yeah. So what do you think? But guys, you gotta take this thing serious. You gotta sacrifice. You gotta put in time. You gotta stay up late, just repeating the same thing over and over and over. Then you gotta be talking it. You gotta know the language. You gotta know the words. That's why when I get to those big words, I stop. And I want you to kind of put them in your mind. Because when you go for an interview, right, the way you speak will tell the people that you know something and that you're educated too. Your terminology, how you put your words really matters. So those are the kind of things we're learning here. So don't take them for a joke. Okay, guys. Yes. I gotta go home. I'm depending on Missoula and he gotta go.
Everybody.
Yeah, good night.
So, Prof, I'm not gonna do now.
Thank you, Prof.
Yeah. Hey, did you finally get that thing?
No, I didn't get it. Anyway,
You couldn't
I'll
log.
try. I got in and it said
Okay.
my search didn't match any documents.
Just hold on 1 second. Let me see something. Just 1 second. Let me first of all share the where is that document? We can give you that chapter something right now before. If I know once I leave, that's it. I'm gonna forget. Textbook 11, chapter 5. Let me do this just a second, and I look for this thing, and I'm going to share chapter 5. So you have chapter 5. Then secondly,
Thank you, Prof.
you're watching my screen, right? Are you watching my screen?
Yes.
Are you seeing my screen?
Yes. Yes, Prof.
Huh? Are you?
Yes, I'm seeing your screen.
Okay, if you're seeing my screen, let me connect into that machine, and you see. No, I will connect into that same machine where you're trying to connect, just to make sure. What is that thing called again? Any desk. So I'll connect to that same machine. So it might disconnect you. So look here now. I'm inside the machine where you are. Are you with me? So if you're watching, I'm sure you're.
Yes, I am.
Okay. So let me just one thing. I want to get the URL is this thing here. This is the thing you needed. Copy that, and I go to, oops, this I minimize the machine. And I go to this thing right here, and I paste it here. That is it. And what I was saying is change that name to the IP address 192.168.1.30. Hit enter. Let's see what it does. Let's see, it's kind of logging in, but I know it can log us in. While it's doing that thing, let me see if that OEM if that thing is running in the first place. Oh yeah, oh, it says it's not running. You see this thing here? When you did it, it said it's not running.
Okay.
So it's supposed to change that to start. You have to start that.
Okay.
That's how come it says the site can't be reached. So when you type that EMCL status, you gotta check and see. It will tell you if Oracle Enterprise Manager is. Here it says it's not running. You see that? So that is why you couldn't log in.
Yes.
Then often it gives you your address. You need this address up here. But you can copy it just up to EM. It's going to work.
Yeah.
Then most of the time it will not like that machine name, so you change it to the IP address. So it may take a while, but after it starts up, if you come back here and do refresh, you can log in. See, just taking its time because that machine is a little bit slow. Yeah, if I had money, I'll buy you. May have to buy a brand new machine. Your flick, Muzu.
Yes, I'll buy one when I come.
Okay. Still doing its thing. But when you finish, whatever it's doing here is going to start. You come back here, do refresh on this button. It's going to log you in. You log in as system with the password sys. Okay. So let me exit. If you log back in, you'll see the screen exactly as it is, or tomorrow anytime you can log. You can log into the machine anytime. But that machine all time. So Okay, let's talk tomorrow.
Yes. Okay.
Okay, good night. Go to sleep.
Yes, Prof.
All right. Bye-bye.
Thank you very much.
And let me